Culturally, we are taught that a healthy adult should be emotionally self-sufficient. Relying on a partner is coded as weakness, dysfunction, or stunted maturity. Clinical researchers Levine and Heller completely dismantle this assumption. Their work demonstrates that dependency is a strict biological imperative. Human nervous systems are hardwired to use select people as an external regulation system. Leaning on others is our primary biological strategy for survival. This means that what clinicians frequently diagnose as codependency or manipulation in a client is actually an under-resourced nervous system executing outdated survival programming. To intervene effectively using the BSM framework, clinicians have to stop treating these attachment behaviors as conscious choices and start treating them as autonomic physiological states. Foundational researchers John Bowlby and Mary Ainsworth identified the attachment system as a hardwired behavioral mechanism. It operates identically to our biological drives for hunger or pain avoidance. In infancy, the operation of this system is highly visible. Maintaining proximity to a responsive caregiver is a literal matter of life and death, and the infant protests any separation. In adulthood, this exact biological system does not disappear. It simply transfers its target from a parent to a romantic partner, forming what is known as a primary pair bond. Levine calls the healthy functioning of this system effective dependency. When a relational bond is reliable and secure, it actively quiets the nervous system. This quieted state generates significant cognitive benefits. It frees up biological resources and bandwidth that the brain can then direct toward exploration, creativity, and high-level functioning. Relational security acts as the biological prerequisite for individual autonomy. We do not achieve independence by eliminating our need for connection. We achieve it by fulfilling that need reliably. About 20% of the population operates with an anxious attachment style, forming the seeker profile. Their nervous system was conditioned in early relational environments where connection was available but highly inconsistent and unpredictable. This audio mixer represents the nervous system to explain anxious hyperactivation, a biological mechanism amplifying connection-seeking behaviors when a bond feels threatened. The seeker system learned a specific rule: turn up the signal to survive, amplifying the need until the caregiver responds. This physiological hyperactivation produces a predictable set of protest behaviors. The seeker engages in obsessive checking, ruminates on past interactions, and escalates attempts to make contact. The nervous system is pattern matching against its historical trauma. Because ambiguity meant danger in the past, even a slight delay in a text message or a shift in tone is immediately read as a severe abandonment threat. The escalating demands of the seeker are not manipulative tactics. They are the nervous system's desperate attempt to ensure a critical attachment figure does not disappear. Roughly 25% of the population operates with an avoidant attachment style, forming the bunker profile. Their early environments either heavily penalized or entirely ignored the expression of need. To survive this environment, the bunker's nervous system learned the inverse biological rule: turn down the signal, suppress all awareness of the need, and rely on no one. Behaviorally, this deactivating strategy looks like intellectualizing emotions, physically withdrawing from the room, and hyper-focusing on hypothetical flaws in the partner to justify creating distance. This creates a dangerous clinical misconception. Both partners, and often therapists, assume that this behavioral withdrawal indicates a genuine lack of neurobiological need for connection. This chart shows physiological data disproving the indifference myth. When in attachment-threatening situations, avoidant individuals self-report little distress, but their bodies show high biological arousal. Internally, the bunker experiences the exact same physiological panic as the seeker. The mind refuses to acknowledge it. The avoidant deactivating strategy successfully suppresses the expression of the need. It entirely fails to eliminate the neurobiological presence of that need. This presents a clinical paradox. If the anxious and avoidant strategies are diametrically opposed, why do these two profiles disproportionately pair together in relationships? The answer lies in the neurobiological concept of familiarity. The nervous system instinctively equates historical patterns with safety, even when those patterns are inherently unstable. When clients describe feeling the spark with an emotionally unavailable partner, they aren't describing actual chemistry. They are describing nervous system activation, recognizing a familiar threat pattern. For the seeker, the bunker's intermittent availability perfectly mirrors their early conditioning. It triggers a low-grade alert state that the seeker's nervous system misinterprets as deep, urgent love. Reliable availability feels boring by comparison. From the other side, the seeker's constant pursuit secretly benefits the avoidant nervous system. The seeker's aggressive proximity seeking provides a silent, ongoing guarantee against abandonment. Knowing the seeker will always pursue allows the bunker to comfortably maintain their required emotional distance without the actual risk of being left alone. Each partner's biological survival strategy accidentally makes the other's historical wound feel like home. This locks them into a perfectly balanced destructive loop. When these two calibrated systems collide, it creates the BSM dysregulation spiral. This diagram maps the initial trigger phase of the spiral. A minor perceived distance, like a short delay in a text response, sets the system into motion. This moves into the escalation phase. The seeker's hyperactivation drives them to aggressively close the gap through escalating protest behaviors. In the lock phase, the bunker's nervous system registers this aggressive pursuit as an overwhelming emotional demand, triggering a profound deactivating withdrawal. The cycle culminates in the shutdown phase. The bunker's withdrawal confirms the seeker's worst fear of abandonment, while the seeker's continuous pursuit confirms the bunker's worst fear of engulfment, permanently locking the system. In this final phase, the seeker is trapped in acute sympathetic mobilization. Sympathetic mobilization is a state of physiological arousal, where the nervous system prepares the body to fight or flee a perceived threat. Simultaneously, the bunker has dropped deeply into dorsal vagal shutdown. Dorsal vagal shutdown is an extreme survival response, where the nervous system pushes the body into immobilization, leading to dissociation and a freeze state. The exact same relational conflict has triggered two diametrically opposed nervous system states. Because of this physiological reality, behavioral co-regulation is biologically impossible without prior intervention. This is exactly why logical conversation fails during the dysregulation spiral, and why the BSM sanctuary sequence is required. The core rule of the BSM approach is that therapeutic intervention must strictly target the underlying autonomic state. Attempting to fix the superficial behavioral output is useless while the nervous system is running a survival protocol. This diagram illustrates the sanctuary sequence. The physiological regulate step must strictly precede the interpersonal relate step. The seeker must downregulate from sympathetic panic to tolerate a pause in connection. Conversely, the bunker must upregulate from dorsal shutdown to tolerate the vulnerability of genuine presence. Only after these two physiological shifts occur can they reach the relate phase. Here, both nervous systems are finally resourced enough to engage with each other without triggering a biological survival threat. Attachment styles are not broken character flaws. They are highly successful historical survival strategies. The primary goal of the clinician is simply to help the nervous system run a vital code update,